Hello, my name is Brandon Becker, Industrial Product Line Manager of Wide Bandgap at Semiconductor. Today I'm going to discuss with you how to utilize wide bandgap in solar and renewable energy applications. This is very exciting because this affects our Earth. This is where we can really see the effects of these materials in our homes and residential settings, as well as big commercial settings that will reduce the carbon footprint around the world. Wide bandgap is used in a variety of markets. Solar, EV chargers, and power supplies are three of the big ones that we're highlighting in a series of videos. And this video today is going to focus on solar, where 307 gigawatts of solar panels have already been installed worldwide today. When we talk about the renewable energy market, it's very important to take a look at what we have today. We're moving from nuclear, coal burning, very polluted energies to newer energies such as wind, solar, that are naturally occurring, that we can harness the energies and utilize them for our consumption. This will make our world, our life, our place a greener, more enjoyable place to live. Some of these policies are being driven at the government level. You can see in Europe, China, and even the United States, where governments are giving subsidies for solar energy, for solar installations in residential area, and for companies using solar energy to power buildings. A few trends that we're seeing in the solar market include 307 gigawatts of power installed today, growing to 500 plus kilowatts of power installed by 2025. Today, 1% of electricity is coming from solar worldwide. This is predicted to hit around 15% over the next 10 to 15 years. Solar power gives individuals the ability to sell excess power back to the grid. It's actually a way to lower your bills and make money. All this is caused from moving from silicon to silicon carbide because your efficiency increases, it lowers the inverter size, and ultimately it lowers the cost of the system. This is a detailed look at a solar block diagram. On the left are the solar panels. Moving from left to right, you can either go to a DC load condition. So this is where we get off-grid power. That's where we can charge batteries, we can use the energy from the solar panels and move them to a portable or renewable storage container. Or we can convert through different inverters to an AC load or on-grid. This is where we can use them in our office places, use them in our work, use them to charge our cars, but also use them to power the grid. Really, the inverter is the center point of connecting the solar panels to a usable power supply. With the addition of SiC being used, we can increase efficiencies by over 3% across the system. One of the key things about the solar inverters is frequency. Frequency typically is very low, which then in turn creates a large transformer, and it allows high surge because the inverters turn on and off and they have a lot of current passing through those inverters. With silicon carbide, it allows us to run at a higher frequency, and it allows us to shrink those transformers. But some of the things that engineers are having to solve is what to do with those surges and also the component count of the system. But we believe today that reducing some of the magnetics in the transformers and increasing the frequency allow us to increase our component count at keeping the same costs or even lowering system costs from before. Wide bandgap is really the solution to all engineers' problem, especially with solar. It really does three things. First, size reduction. The whole system is much smaller, moving from silicon to silicon carbide. Second, it's an efficiency and performance improvement, and we see up to 73% reduction in losses. Third is cost. We can see today that the cost of a system is actually cheaper at a BOM level than a silicon solution. Now that we've gone through what silicon carbide is, how it's manufactured, some of the benefits that go along with that, Let's take a look at ON Semiconductor's portfolio. We have a very large portfolio that range from diodes to MOSFETs. Our diodes include 650 volt and 1200 volt through-hole, surface mount, die, and modules. Our MOSFETs are released at 1200 volts with 900 volts and 650 volts coming in the near future. All of our products have high level of quality and reliability, which include undergoing AEC-Q 101 testing. Thank you for tuning into this video about utilizing wide bandgap in solar applications. I hope you learned a little bit about how silicon carbide is utilized in these applications. Please also make sure to tune into some of the other videos that include the EV, electrical vehicle charging stations, as well as how wide bandgap is used in power supplies. If you have any questions or need more information, please visit us at onsemi.com. Thank you.